Hello, welcome to Maths 205, Abstract Algebra 1. I'm Imam, a lecturer at the Department of Mathematics, Ahmad Bello University, Zaria. This is Lecture 1, Introduction to Propositional Logic. So, what is logic? Logic is the systematic study of valid reasoning, inference, and truth. It provides the principles and method for distinguishing correct reasoning from incorrect reasoning. In essence, logic examines how conclusions can be validly drawn from given statement. These given statements are called premises. So given some set of statement, which valid statement can be drawn from a given statement. This is what logic is doing. Actually, logic is actually a study of valid reasoning, inference, and truth. I give you example here of valid reasoning. What we mean by valid, so I will give you an example of an invalid reasoning. So consider here two statements. All birds have wings. And another statement that says a sparrow is a bird. From these two statements, one can deduce that a sparrow has wings. So this is a valid reasoning because you are told that all birds have wings and a sparrow is a bird. So from the statement that every bird is having a wing, wings, you can deduce that anything that is already identified to be a bird is also having wings. So this is a valid reasoning. A reasoning that may not be valid is to have some birds can fly, and then from these two statements, one deduces a pigeon can fly. This is an invalid deduction because when you say some birds can fly, that doesn't mean anything that is a bird can fly. So from the fact that a pigeon is a bird, you cannot conclude that it can fly because you are only informed that some birds can fly. So even though it is true that a pigeon can fly, but it's an invalid reasoning from the given premises. You cannot deduce from the given premises this true statement. So this is what we mean by invalid reasoning. And in fact, logic helps us avoid such an error by formalizing the way we think. So logic dates back to ancient Greek philosophers, approximately 600 to 300 BC. And the most outstanding logician among them was Aristotle, who formulated the earliest system of deductive reasoning. And during the time of Aristotle, most of the philosophers are studying logic not from the mathematics point of view, not using symbols to analyze statements. But then in the 19th century, British mathematician George Boole laid the foundation for symbolic logic in his textbook, An Introduction to the Laws of Thought, on which are founded the mathematical theories of logic and probabilities, published in 1854. In this book, Boole suggests that letters, just like in algebra, can be used to represent statements, and that operations can be carried out with statements similar to the operations in algebra, where you can add, multiply, subtract, divide numbers. Boole suggests that we can perform such type of operations with statements, and thereby resulting into a formal analysis of the statement, so that valid reasonings or valid deductions can be drawn from the statement. And the type of algebra that is being formalized is now that was suggested by Boole is now known as Boolean algebra, an aspect of algebra, which we are going to study in this course. Later in the 20th century, there are the contributions of mathematicians or logicians like Frege, Russell, and Gödel, who contributed in the area of symbolic logic, and their contribution transformed logic into a formal symbolic discipline. And it is now most of their contribution that laid the foundation for what we call mathematics today. So logic is divided into two main types: informal logic and the formal logic. Informal logic focuses on natural language argument, rhetorics, and fallacies. And this is the kind of logic that was being considered during the time of Aristotle. No much symbols are involved, no formalizations of statement. So language is just being analyzed in its own raw form without having to look at the generality of the overall effect of the argument. But then formal logic is using symbols as framework with precise syntax and semantics to study validity and inference. But this type of logic is further subdivided into two: the formal logic, one we call sentential logic or propositional logic. Some will also call it propositional calculus. And in propositional logic, we study logical relations between sentences, or what we call propositions, treating each sentence as a single unit. So it's not the task of propositional logic to analyze the internal structure of a sentence or statement. Like, for example, if you look at the statement, humans are mortal, this statement is made up of subject and predicate. So it is not the task of propositional logic to analyze the relationship between subject and predicate contained in a particular statement, but it just treats the entire statement as one single entity and look at it as being true or false. So that is the task of a propositional logic. Another aspect of the formal logic is the symbolic logic, which is a broader term that refers to the use of symbols and formal system to represent logical reasonings. And it includes also the sentential logic or propositional logic in the first category. It's also captured under symbolic logic, but it goes beyond propositional logic to cover predicate logic, where we use functions, variables, and quantifiers to represent statement. And it also covers model logic that takes care of necessities and possibilities. Temporal logic is also included under symbolic logic. For certain statements are time based statement, because some reasoning are dependent on time. So these are all aspects of symbolic logic. But our course, in this particular course, Maths 205, we are only going to concentrate on propositional logic and predicate logic. So we define what a proposition is. So what is a proposition? A proposition or statement is a declarative sentence that is either true or false. Declarative sentence in the sense that it declares a certain fact so that you can answer it true or false. For example, if you say Zaria is a city in Nigeria or a city in Abuja, you say Zaria is a city in Kaduna. It is true because we know that Zaria is a city in Kaduna. So this is a true statement. It declares the fact that Zaria is a city here in Kaduna. So it's a declarative sentence, and these are the kind of sentences that we consider in mathematics and in particular in logic. We don't deal with statements such as sit down. If you ask somebody to sit down, there is nothing to, and it's just a command. You don't have anything to analyze as to decide whether the particular statement is true or false. So that is not a proposition in mathematics. A proposition is a statement, declarative statement that you can analyze as to be true or false, but it shouldn't take both true and false value. We shall be using throughout the discussion letters such as P, Q, R, S, and so on, lowercase letters, to represent propositions. And we assign to a proposition P a letter T when it is true and a letter F when it is false. For example, Zaria is in Nigeria. This is a true statement. Then we assign to it a letter T. We say the truth value of that statement is T. And if a statement is false, then the letter is F. So the letters F and T are called the truth values of the proposition. So more formally, one can just define a proposition just as a variable that takes two values, T and F, and no other values. Examples of propositions. So the following are propositions with their truth values. If we say Zaria is in Nigeria, this is a statement, it's a declarative statement, and we can answer it as true or false. But if you look at the statement, it's a fact. It's declaring the fact that Zaria is a city in Nigeria, and so therefore it's a true statement. So it has the truth value T. And if you say 7 plus 11 is equal to 711, this statement is declaring that when one adds 7 to 11, then he has 711 as the result. This is a declarative statement, and so therefore it is a proposition. But then it is a false proposition because we know from our knowledge of addition of numbers that if you add 7 to 11, you get 18 and not 711. So it's a false statement, so its truth value is F. And likewise, ABU is a polytechnic in Zaria. This is a declarative statement, and so therefore it is a proposition. But then it is not true because ABU is not a polytechnic in Zaria. It is a university in Zaria. So therefore it's a false proposition. And then the fourth one is to say that 6 is an odd number or 5 is a prime number. If you have 6 is an odd number, this is not true, or 5 is a prime number. This is a declarative statement. It's saying one of the two must be true. That is, either 6 is an odd number or 5 is a prime number. But we know that 5 is a prime number. So the entire statement here is a true statement. And so therefore it's a proposition and its truth value is T. Examples of statements that are not propositions, or sentences that are not propositions. So if you make a statement like saying keep quiet. So if you say keep quiet, this is not a proposition. It's not a proposition in mathematics because it's not a declarative statement, it's just a command. And you don't answer this as whether it is yes or not. You can analyze this particular statement to see whether it is true or false. And if you say x plus 11 is equal to 711, well, this is either true or false. In fact, it can be true, it can be false. But by our definition of proposition is we say that it's either true or false. So it shouldn't take both values. So, and this one is you cannot answer it immediately until you tell me what x is here. So depending on the value of x, if I substitute x to be 700 here, then I have a true statement. And if I substitute x to be anything not 700, then I don't have a true proposition. So this is not a proposition, but it can be converted into a proposition by assigning a specific value for the variable involved there, x. And this is the type of statement that we will later on call predicates, and we are going to look at them. And this is actually what predicate logic is going to study. And then, how are you? If you say how are you, this is just a question you ask, so it's not a statement. If you say it is a cold day, it is a cold day. If you say it is cold today, then this one is a statement because you are talking about the very day you are making the statement. It is a cold day. But if you say it is a cold day, it's just like this number 2, x plus 11 equal to 711. So therefore, this a day is a variable involved there. So you cannot say which until you say which day is it. So it is not a statement. I give you exercises here. You can pause